Hello and welcome to part 3 of solving rational inequalities. This is the final part of the rational inequalities videos. All right, so let's take a look at what we have. We have 4 over x plus 3 is less than negative 2 over x. Well, this is not set up and ready to go, mainly because right now we don't have 0 on one side of the problem. So first, let's add that 2 over x to the other side. So that gives us 4 over x plus 3 plus 2 over x is less than 0. All right, so now we got the 0, but what don't we have over here? On the left side, we have 2 fractions. All right, so remember, you're supposed to have 1 fraction. So how do we make that 1 fraction? Well, we can just add them together. So in order to add fractions, we need a common denominator. And remember, the common denominator is found by multiplying your denominators. So multiply x plus 3 with x. Now, you could leave it like that, or if you want to multiply it out and get x squared plus 3x, I guess that's fine too. But keep it in factored form because it might be useful later. All right, so now let's transform our denominators. So the first fraction, 4 over x plus 3. I would like to have that x there, right? So that's my common denominator. And I can do that as long as I multiply the top also by that x. So now I just set up the first fraction with the common denominator. Bring down the second fraction, plus 2 over x. Remember, the common denominator is x with x plus 3. So tack on the x plus 3. And don't forget to tack that on the top also. Don't forget, less than 0. All right, now at this point, you can just simplify all this. Less than 0. Sorry, it's a little sloppy. So my denominator is now x with x plus 3. And remember what you do? You combine the numerators, right? So the numerator of the first fraction is 4x plus, and now 2 times x plus 3 is 2x plus 6. I can simplify that just a touch more by making that 6x plus 6 over x times x plus 3 is less than 0. All right, so we're going to box this off. This is what we're going to use from this point on. All right, so step number 1. You need to first find the zeros of the function. And remember, you use the numerator to get that because your numerator can equal 0. So take your numerator, 6x plus 6, set it equal to 0. So solving for x, simple enough, you get negative 1. The next thing, find out where the function is undefined. Well, remember, that's now using the denominator. The denominator can never equal 0 because, remember, division by 0 is undefined. So, remember I said before, keep this in factored form. Solve this as if this were equal to 0. So you would take the first factor x, set it not equal to 0. Take the second factor, x plus 3. That also cannot be 0. So the first one's already done, so x can't be 0. And then here, subtracting 3, x also can't be negative 3. And then the top number there, x equals negative 1, is the 0 of the function. So now we can do our number line test. All right, so you're going to put the infinity symbols on there and the 3 numbers that we just found in order, negative 3, negative 1, 0. And remember, that line represents all x values. On top of the line, we're going to be representing the signs of the y values. And remember, the signs of the y values could be positive, negative, 0, and undefined. So let's record what we have. So for x equals negative 1, we're going to put a 0 on top because that's the 0 of the function. And then on top of the other 2, remember those are undefined, so put that there. All right, and now we have 4 sections that this line is broken up into. So in other words, we have 4 intervals to set up and test. So let's pick some numbers in each interval. So numbers like x equals -4. In the next interval, -2 seems to be a good pick. X equals -0.5. And x equals 1 in the last interval. And we get the y value for x equals -4 is -4.5. For x equals -2, we get y equals +3. Here we get y equals -2.4. And for x equals 1, we get y equals 3. And again, I'm getting those values by plugging the x values into the equation that's in the box down here on the left side, right here. Okay? So I'm plugging the x values into the left side to get those y values. All right? So now on top of the number line, we're going to record the signs of those y values. So we're going to put a negative here because the y value is -4.5. Here we're going to put a positive sign because the y value is +3. We're going to put a negative there for -2.4 and a positive there for the +3. And now we're just about ready to write out our solution. So the solution is all x such that what? So let's go back to the equation, or excuse me, the inequality in the box. The inequality, all right, says that the function has to be less than 0. What does it mean to be less than 0? It means anything that is negative. So go to your number line and on top circle the portions that have negative signs. So we don't have a whole lot here to cover. So this section is negative and this section is negative. So you shade those in. And now start putting in parentheses or points, whatever you prefer. So remember, with infinity symbols, we always use parentheses. At the -3, we did not include it because it's undefined. So that would be an open point or parentheses. All right, now at -1, we did not include the 0 there. So we put an open point or a parenthesis. And then on the right side of that, it's 0. It's undefined there. So that's an open point or parenthesis. So therefore, our final solution are those two intervals in blue. So you would write -infinity to -3, parentheses. And since there's a second interval, we're going to union them. And that's -1 to 0. And there's our solution. I hope you found this video helpful. I am the Math Musician. Please subscribe to my channel and check out my other videos. Some are math and some are music with me on the piano. Thanks so much for watching.